What if you had a one-dimensional list of data that needed to be split over multiple columns or a 2D grid for some machine learning model that you're trying to create? Or you had data collected over multiple times and you need to merge them together just so you can pass them all into your analysis project. Or you had data from two different sensors and you need to merge them together into one data set. This is where reshaping, flattening, and stacking array come into play. In this video, we're going to talk about how do you reshape your data into different dimensions or different layouts, and I'll explain why would we need to do that. We'll also talk about how do we flatten them back into a one-dimensional array, and then finally, how do we merge data together and stack them together, whether that is vertically or horizontally. All of these are essential when preparing or combining data for analysis, for machine learning model development, or for visualizations. Reshaping is common when your data is being collected as a one long sequence, but your model or your analysis requires them to be split over multiple columns. Sometimes your data or your logs may have the data all as one big chunk of data, but you know that they are cyclical, meaning that the first item is going to go into property A, the second is property B, the third is property C, and then we start over again, and now the fourth item becomes property A, so on and so forth. This is where reshaping comes into play, and you're able to merge this data or realign this data into the proper shapes or the proper arrays that you need them to be in. We've kind of talked about reshaping earlier, but let's reiterate again. If I had an array here, and this is a Numpy, a range to 12, stop at the 12. Here's what that would look like. But then I'm able to reshape this. So this is my one long sequence that I need to reshape into a different structure. So if I do array, reshape, and I want this to be a 3x4, this will reshape my array into a 3x4 grid, meaning that I have 3 rows and 4 columns. The data here doesn't change, only the layout does. And this is crucial when you're converting some raw data into the format that your model is expecting. Now, sometimes you want to go the other way around, where you have a multi-dimensional array that you need to convert into a single list or a single array or a single vector. This is common in machine learning pipelines. For example, if you have an image that has a set number of pixels, you want to flatten this into a single vector that you can pass into your model as a single feature or as a single array of data for processing. So to do that, let's create a new list, array2, np.arange, and I want 6 numbers here. And I'm going to reshape this already into a 2x3. So this is my array2. And now if I want to flatten this, here's my flat copy. We'll call array2.flatten. And if I print this out now, you see how it puts them all as one line or one structure. Now, this is more safe because it actually takes a copy of the data, but it also uses more memory. The alternative to that would be if you do flat2, this is array2.ravel. Now, what this does here is that it actually returns a view if possible, and it represents it in a flat way. So it uses less memory because it did not need to create a copy, but also that means that if you do modify any of your items here, it will be modifying the original array that we started with. So flatten is safer if you want independence from the original data set that you're working with, while ravel is faster and more efficient when you just want a quick view into the data, only represented in a different format. We also often need to rotate our data or swap the rows to columns and columns to rows. So for this, we would use the transpose function. So if I have array, let me call it array3 now, and this is a Numpy, a range of 6 numbers reshaped into a 2x3. Here's what my array3 looks like. Now, if I do array3.t, this will convert my rows into columns and my columns into rows, or what we call in math transpose. All right, so now what if we wanted to merge data together? What if I have two sensors that are collecting data at the same time frames, and I just want to stack them together so that they fit in one big data structure that I'm able to use. Here we have two ways that you can merge your data, either as a horizontal stack or as a vertical stack. Do you want them added as extra rows, or do you want them added as extra columns? So let's go ahead and demonstrate that. I'm gonna copy these two arrays here. All right, so if I wanted to vertically stack this, I will do numpy v stack. And here I'll provide the arrays that I want to stack together. So I have A and I have B. And this will stack my two arrays together. If I wanted to do a horizontal stack instead, let's do np.horizontal stack. And this will look a little bit different because I'm going to try to stack this array with another np array that will create, but this will contain the number 7 for one column and the number 8 for another column. It'll make sense when you see it now. So what happened here is that if we look at the original A, it basically has two nested lists right here, or nested arrays here. So we needed to create another nested list that represent whatever the value that needs to go into the first array and what is the value that needs to go into the second array. So now when we horizontally stack them, we get the 1, 2, and 3 and 4 from the first one, but then we add up the 7 and the 8 right next to them. All of these tools and utilities are things that will be extremely necessary and extremely helpful when we're trying to prepare our data for machine learning modeling or for any sort of data analysis. So here we use reshaping to prepare our data for algorithms. We use flattening to convert, for example, images into a single feature or a single column that we're able to process. And we learned about the transpose function that will convert rows into columns and vice versa. And finally, we talked about how we can merge data sets together, whether these are data that are collected over time from the same sensor or data from different sensors that we want to add up together just so that we can create a full featured data set that we're able to use for our processing. Now, that's a wrap for our NumPy basics. Next, we're going to move on to pandas, which will allow us to add labels and work with the data in more like a table-like format where we can assign names to our rows and our columns here. After that, it will all be data analysis, data science, and machine learning, and we'll be good to go.